Hi guys, this is Faizan and welcome to today's session on data structures and algorithms for tech interviews. So before I start, can you guys quickly confirm in the chat if I'm audible or not? Is everything okay? Can you see me? Can you see the pointer? Can you see the slide deck? If yes, then write a quick yes in the chat. And in the meanwhile, while we wait for others to join, let me give you a quick tour of how our academy looks like. So when you type in Great Learning Academy, therein you will get this first link. Just click on it, right? Just type in Great Learning Academy on any browser you have. Then you click on the first link, and then it will redirect you to this page, wherein you have all the live sessions that are upcoming live sessions. This one is there. Tomorrow we have two sessions, one at 4 and one at 1 p.m. Okay, so these are the live sessions. If you want to view all the live sessions, you can just click on this and it will show you. Plus, if you're looking for some advanced PG courses, we have those available as well. Just click on it. Let me click it and show you what are the courses there. So we have data science, AI, machine learning, management, cloud computing, cybersecurity, software development, and design thinking. Okay, so apart from that, we have free courses like these. These are our popular courses, right? We have digital marketing there, machine learning, Python, Python in Hindi, right? Data visualization, cloud foundation, Excel for beginners, right? So these are all our popular courses. If you're looking for something that is related to IT and software, Java, Python fundamentals, ethical hacking, cybersecurity, blockchain, MySQL basics, right? So these are all our IT and uh, software courses, right? So if you're looking for something that is related in Hindi or you want to learn in Hindi, we have courses in Hindi as well. Now once you have completed this course, right, and you have completed all those things, all the assignments that are there, at the end you will have a quiz. In that quiz you have to answer 6 questions correctly out of 10 in order to get the completion certificate. Okay, cool. That you can easily add in your resumes and in your LinkedIn profile, saying that okay, I did this course and this is my certification and I built this thing. Then you need to justify those things, okay, when you are giving an interview. So cool. So now let's get started. I can see some yeses. Okay, great. Okay, so what are the things that we are going to cover in this session? First, we will talk about why we need data structures, what is a data structure, what is the importance of data structures. Then we will talk about arrays, we'll talk about its implementation, simple stuff. We will start with simple stuff, okay? Then linked list, and I'll also talk about some questions that are there that are asked regularly, frequently in all the tech interviews, right? Then we will talk about stack. So similarly, you can follow on queue as well, right? So obviously that though they have a small variation, but I'm not going to cover all those things because this is a 1 hour session. So I'll give you an intuition how queue works. But yeah, in this session, we're going to cover stack and its implementation, both in arrays as well as in linked list. Then we will talk about algorithms and we will talk about searching algorithm and some sorting algorithms. Okay, I know this is not it, there is much more to it, but yeah, in this session, since it is a 1 hour session, we're going to focus on these things. Okay, so now what is a data structure? If you can see, okay, yeah, hi guys. So if you see that this data structure contains two words, data and structure. So obviously when you know how you are structuring your data in the memory, obviously uh, you can have a look or you can feel how you are fetching those things like CRUD operations, right? Create, fetch and update, delete. Okay, so these are all operations, right? So you can focus on them and you will know how you're fetching your data so that you can understand the time that is associated with this data structure, or you can say the space associated with this data structure, that can be obviously calculated. So when you know how you're structuring your data, meaning how you're arranging your data, and obviously now this data is your information. It won't be a raw data, it will be your information that you want to store in your system. Okay, so now this contains two words, data and structure. Okay, now if you talk about in a naive way, it is a way to arrange data in computers. Now in computers, when you talk about, now you see the significance of these things, right? Data structure. Now if you know your data structure well, you can easily calculate different things. Like if you talk about hash sets or hash maps, okay, or even hashing, right? The great thing about this hashing is that all the operations, like if you want to check if you're checking for an element in the hash set, it will take a constant amount of time. Okay, so that is the beauty of that thing, right? If you talk about stack, if you're using stack, now you know, okay, if you're pushing, it will be a constant time operation. If you are popping, it will be again a constant time operation. So you can calculate these things, and in order, or when you're dealing with these things, you can in a whole, you can calculate the time complexity of your whole program. Okay, so that is the beauty of this data structure and why it is important. Okay, so now if you talk about some linear data structures, there are different types of data structures, like linear data structures wherein you have arrays, linked list. Obviously stack and queue also follow in that paradigm, like linear fashion. But yeah, we have some restrictions when you're talking about stacks and queues. Okay, then you have hierarchical, wherein you want to show the relationship between a child and all those things. Therein tree and graphs comes into picture. Okay, so let's start with the basic what data structure that is there, which is our array. So if you talk about these companies, like small basic companies which are there, like TCS, Wipro, all these have low packages. That is why they focus on not DP. That is the one programming paradigm, that is dynamic programming. They don't focus on graphs, obviously, right? So they focus on these data structures like arrays, stacks, queues, linked lists. They focus on these things, and they will ask you coding problems regarding those data structures. Okay, so mostly they will focus on arrays because there's a huge, when I talk about huge, there are millions of questions that you can possibly have when you're dealing with arrays. Obviously now you have to use some more things, like you will use array list, or if you talk about Java, right, you can use array list, you can use linked list, so in order to solve those questions. Okay, so now let's start with arrays. So let's understand what an array is. So obviously when you're talking about array, it is a linear data structure. That means elements are stored in a linear fashion. Okay, it is that data structure wherein, if your memory, let's talk about this memory allocation, right? So if you have a memory, this is your memory, and in your memory everything is occupied. Okay, and you have chunks of memory available here and there. Let's suppose here you have 4 bytes, or let's suppose you have 8 bytes, and here you have 8 bytes. Rest of the memory is occupied. Hypothetical situation. Okay, now when you're dealing with arrays and you want to store an array with 4 elements, and all those elements are integer elements. So integer takes 4 bytes. When you talk about the size of the integer, okay, int takes 4 bytes, and you have 4 elements. That means 4 into 4, that is 16, right? And you have 16 memory available, right? But those are available in chunks. Can you store elements, or for those 4 elements in this memory? Yes or no? Quickly, just write in the chat, yes or no. Kashyap says yes. Okay. Anyone else? Quickly, guys, can you or can you not store this 4? What is the difference between contiguous memory and continuous memory? So these terms are interchangeable, right? So you can change them, but yeah, when you talk about something else, continuous means which doesn't stop, which is not discrete. That means, like if you talk about analog and digital circuits, right, at that time you have continuous signals, right? Those are not discrete. One is flat, one is though. But yeah, right, in this situation, in this, when you're dealing with data structures, these terms are interchangeable. Okay, and say that these means a simple thing. Contiguous, I will let you know what is this when you're talking about arrays. Okay, what is a contiguous memory allocation? Okay, so some of you say yes, some of you say no. But now you cannot store, right? Now the reason is that it is stored in a contiguous memory allocation. Now what do you mean by contiguous? One after the other, right? So you have, if you have these 8 bytes and 8 bytes together, that means these 16 bytes are available, and they are available in a single chunk. Let's suppose this is 1 2, and let's remove this. One second. When you have this array available, and this array is available as a whole chunk, right, like here, there you have 4 elements, only then you can store your 4 elements in it. Let's suppose 1 2 3 4 integer array. Okay, so because this is why elements are stored. This is the reason behind this, is because array stores elements in a contiguous memory allocation. That means one after the other. So with the help of this, when you have this situation, only then you can fetch something directly. Okay, because in arrays there's a beauty associated with arrays. Also there are drawbacks, but when you talk about array, therein you can randomly access elements, okay, randomly. Now it is due to the fact that they are stored in a contiguous memory allocation, and you know, if this is 100, this will be 104, and this will be 108, and this will be 112. Okay, we can't, sir. Okay, great. So now when you have this array available, that is the name of the array represents its base address. When you talk about this ARR of 1, you know this is the base address plus 1. That means this is you can say that this is something that is related to the size. This 1 is related to the size of integer. So this means 100 plus 4. Only then, okay, can you guys see this? I hope you can. Okay, let me put it over here. So it means 100 plus 4, that means 104, and you can access this location directly. Why? Because you know for the fact that, okay, when you talk about arrays, we have contiguous memory allocation. Okay, is this thing clear, Akram? Is this thing clear? What do you mean by contiguous, and what are the advantages when you are talking about contiguous memory allocation? Okay, so I have written whatever you are not able to see, I have written that over here. Okay, so this is what you can say, that elements are stored in a contiguous memory allocation, and with the help of that you can directly or randomly access elements. Now there is one more thing that is associated with arrays, is that elements are stored, all the elements. Let's talk about this array. If you have an integer array, right, you're talking about integer array, right, you can only store integer elements. That is what you mean by homogeneous elements. So new is used to allocate memory, and that thing, the malloc, is used in C. Okay, obviously these things are again similar. Both of them are used to allocate memory. Okay, and both of them store memory, allocate memory in the heap, right? When you talk about malloc, this is used in C, and when you talk about new, this is used to create objects or allocate memory in Java. Okay, so Priya says no. Okay, cool. So now let's continue. Okay, if you talk about syntax, right, now the syntax is that, you have first the data type. That means which elements are you trying to store. That is int, you know the data types, right? Int, float, char. Okay, these are all the data types that you have. And then the variable name, that is the name of your array, along with this curly the square brackets, or you can say that this is a subscript. Okay, then you, in this subscript, you will define the size. Okay, so this is your var, and you will name this array. Let's suppose we are naming this array ARR, and then you will specify the size over here. Okay, now you can specify a size here, or you cannot specify a size here, depending upon when you are declaring it. If you're only declaring it, then you will specify the size, and then you will use, or you can use any scanner class, or when you talk about Java, you can use any scanf statements to enter the values. Now if you want to let's suppose declare an array in Java, how you do it? This is int, name of the array, then the square brackets, then new to allocate memory, and then the data type, then the size. Okay, sir, negative can also be stored. Yes, Ravi. You can store any integer. When you talk about integer, that includes your negative, your zeros, your ones, your positive as well. Okay, so this is how you declare in Java. Okay, obviously now declaration and syntax will differ from language to language. Okay, and see, if you want to declare an array, or you can directly do ARR, and that's it, right? You will declare it. You don't need a malloc. Okay, so at that time, this is how you declare it. And in Java, if you put it like, there are two ways with which you can put this subscript sign in Java. You can put it over here, as well as you can put it over here. Okay, both are valid in Java. And when you want to declare a array wherein you are trying to initialize it at the same time, okay, at that time what you are doing, you are declaring ARR, and then the size of the integer. Then you don't put anything in your square brackets, and then you put 1 2 3 4. Okay, yes, plus z to minus z, you can say that. Yes, obviously the range is, you have 4 bytes in right, so the range will be minus 2 raised power, you say 4 bytes, that is 4 into 8 is 32, you say 31, to 2 raised power 31 minus 1, because 0 is also included, so that is why minus 1. Malloc, when to use malloc, not in this is something that implementation is dependent on that malloc. You will use that malloc when you're trying to deal with what, C language, and therein malloc is the guy who is responsible for allocating memory. Okay, Okay, so now this is your declaration and initialization. Okay, so if you talk about advantages, I'm trying to keep this as much language agnostic, that means language independent as much I can. But yeah, if there are some dependencies, I will let you know that I'm using Java. Okay, so if you talk about advantages here, right? So obviously now one of the advantages is that you can directly access things, right? If you have this array and you want to go at this particular position and you know the size and you know the index where you want to go, you can directly say ARR of 3 and you are directly over here. Okay, okay, so that is random access. You can easily sort. Okay, you can easily sort and iterate through this array. So obviously when you have the, we will talk about one of the sorting algorithms. Let's suppose bubble sort is there. You just apply bubble sort over here and done your sort. Or if you don't want to apply any kind of sorting algorithms, you just write two for loops and then you just iterate through all the elements that are there. That is basically what happens in bubble sort. That is one of the most naive and basic, that means brute force algorithm. Okay, that means straightforward. Okay, naive, you can say basic algorithm, you can say brute force, that means straightforward algorithm. Obviously that also includes these for loops, and one by one you are iterating through all the elements, and at the end you will have this element at the end, and this is the largest element in the entire array. So you can sort easily, you can iterate easily with the help of single for loop. You can iterate through all the elements that are there in the array. Okay, done. And if you want to replace a multiple, now what does this thing mean? Can anyone tell me in the chat? What does this thing mean? Replacement of multiple variables. Yes, Muskan, you can also watch it later, but I will suggest that you watch it right now so that if you have any confusion, you can ask me right here. Quickly, just tell me what is the last advantage. What does that mean? Quickly, guys. Yes, you can. You can store, Pragyan, you can store characters in an array. So basically, what does this mean? Let's suppose you have a bunch of students. Let's suppose you have 10 students and you want to store the roll number in that. Let's suppose you have roll number 1 and you want to store 1. You have roll number 2, you have roll number, let's suppose you have roll number 1 and then 2, you want to store 20 in it. That means this roll number is present, and you want to store all the 10 roll numbers in your memory, and you will be using, if you don't know an array concept, right? Yeah, yes, Abhishek, yes, perfect. So if you want to store these 10 variables, now in order to now there are only 10 variables right now, right? Let's suppose you're now, I'm talking about 1,000 roll numbers. Now will you go ahead and create one by one all these variables up to 1,000? Sir, this is only for interview. Yeah, Priya, you can take it as an interview. I will also talk about some interview questions. If you want to learn something, right, this is your first session on data structures, you know nothing, you can also go through it. It is for both the beginners as well as the advanced guys. Okay, not particularly for interview. Okay, so I will be talking about more over interview questions as well, so that you guys can understand or relate these data structures. What are the questions that are going to be asked? Okay, so collection of characters is called a string. Yes, similar type of variables. Yes. So if you have now 1,000 variables and you want to store the roll number in that, now you go ahead and create those 1,000 variables. Instead, if you use an array, then you only need to change the size. Let's suppose earlier we were talking about 10, now you're talking about 1,000, and one by one you are going to store all these elements or all these roll numbers inside this array, and you can name this array as roll number and then start inserting the values in this array. Okay. Okay, so now these are the advantages. Now what are the disadvantages? Obviously it is obvious to you guys, implement algo. So we will also implement algo here. Yes, Ravi, yes, we will talk about some algorithms as well and how you can use them when you're facing an interview, right? They will not be asking you straight away, write a code of bubble sort. There will be some companies, but not all of them. There's a one-off chance, like if you are giving 50 interviews, in one interview they might ask you straightforward question like try to implement merge sort, but that is not going to happen. Okay. Background. Okay, I'm learning this only for knowledge. Okay, Priya. Okay, you can watch it. Okay. Okay, great. So now what about the disadvantages. So obviously when you talk about arrays, the size is fixed. You have to define a size, right? And you cannot exceed more than this, right? Let's suppose you want to store 10 elements in this array or 15 elements. You cannot, because size is fixed. And it is one of the other drawbacks that is there with this size, that if you have declared an array of 100 and then you are trying to store only two elements in it, and rest of the 98 elements are wasted, right? You're not storing anything. That means 98 into 4, that is bytes, 1 byte for each integer. This much memory in bytes is wasted, okay? Just multiply it. 4 is 32 and 4 9 is 36. 392 bytes, if I'm correct, 392 bytes of memory are wasted, okay? So that is also the drawback, and it is difficult to insert and delete. Why I'm saying that? Because if you have an array, right? Sir, how to clear concept of these? That is what we are trying to do here, Sunil. So just wait, give yourself time. So we are going to cover these concepts, all the concepts, not all the concepts, but yeah, we'll start building upon something, okay? So now, what is this insertion and deletion? Why it is difficult? So basically, when you talk about this deletion and insertion, let's suppose you have these elements, right? 1, 2, 3, 4, and you want to insert an element because you have one size available, so you can insert an element. Now, what happens over here? If you want to store an element or insert an element at this particular location, you need to swap all these three variables. Now, you will be swapping this to this, this to this, this to this. That means 2, 4, 3. And then you will be storing your new element, let's suppose 8. So a lot of swapping is required when you're trying to insert. Similarly, now let's suppose you want to delete this element, again you need a swapping, so that no memory is kept in the array that is not used, okay? So C++ or Java, which one is more useful for interview? So if you're trying to practice now, in, let's suppose you're trying to practice in lead code, that is one of the best websites. Then there is GFG, Geek for Geeks. Then there is Hacker Rank, Hacker Earth, all these websites, right? So if you are looking for that is CP, that is competitive programming, right? If your interview, now it depends from company to company, obviously. Now if you're trying to compete, right, you're trying to go into competition wherein your memory and all those things, your fastness of the language is dependent, right? Therein one of the best languages is there, that C++, and after that there is Java. So you can easily use one of these languages, okay? Now if you're trying to give an interview and you don't want to change a language, you have interviews coming up, then I suggest whatever language you know, just start building or start using your data structures and algorithms and start implementing them in your own language, not change your language, okay? Okay, cool. So now what about the other things? Obviously, when you talk about the disadvantages, it needs contiguous memory, because we know if you don't have contiguous memory allocation, you cannot store them, okay? Because they are, if you have chunks of memory here and there, you cannot store elements, okay? Done. So now if you talk about applications, when you're trying to store your information in a linear fashion and your application requires frequent searching, at that time you can use this array data structure. Now if you talk about implementation, this is the Java implementation. Obviously, if someone knows Java, then it is easy for him. If someone does not know Java, let me give you a brief introduction how Java works, okay? Sir, how to learn competitive programming? Implementation, practice, okay? Pick a language. If you already know a language, start implementing your data structures first and then shift to algorithms. And then try to do not follow or do not fall in this trap of learning without implementation. Just learn something. Let's suppose today you learned stack, okay? Now go in your lead code and start implementing. See the questions that are already there in the lead code which are used, or let's suppose you have a program there and in that question you have to implement stack, but it is not directly given to you use stack. You have to think, okay, I can use stack. If lead code is a little bit complicated for the start, if you're just starting it, I suggest go for Geeks. Therein type stack questions, okay, wherein you can use stack. And that obviously Geeks for Geeks have a good archive of these stack questions. Also every data structure that is there, they have a good archive, and the questions are based on, let's suppose you want to implement stack, you can just write stack Geeks for Geeks. It will show you the questions wherein you can use stack to implement those, okay? Done. So if you talk about arrays now, if you have sir, how much Learn DSA in Java for placement. So obviously, when you talk about, it depends from company to company, right? So if you're aiming for, let's suppose, Amazon or what, mm, Google or Facebook, then you need everything. There is nothing you can leave, including DP, graphs, everything, right? Trees, AVL tree. Sometimes they will ask you to create a game as well. At that time, you cannot leave anything. But if you're focusing on companies apart from these, then they will not ask something that falls under these two domains, graphs and DP. If you're Okay, sir, I am conscious about CS because of the requirements of IT nowadays and India need. Yes, Priya. Okay, yeah, I do. Okay, please start the DSA using Python course in GLA. Sure, sure, Kashyap, we will work on it. Kashifa, Khurshid says C++ plus plus or Java. C++. Plus plus. Sir, is there any technique to reuse the memory which are not being used in array declaration, like memory release or no? If you want to, that is a drawback. That is why we have array lists in Java, or in other programming languages you have linked list, wherein you can use your memory much more efficiently. How it looks in C++ plus plus language, okay? C++, Java or Python. C++, okay? So if you don't know any of them, so you can go for C++, okay? So now let's try to understand. You have used a scanner, that is basically your scanf, and you talk about C and C in your what in your C++, okay? Then you will iterate through the indexes and try to ask the user to enter values. Once he has entered all the values, then what you're trying to do, one by one, you are just printing them, okay? That's it. So now let's talk about linked list, which is much more good data structures, and there are a lot of questions that are asked, okay? So now before moving to linked list, let me pose a question for you guys, okay? So let's suppose you have an array, okay? You have an array, and in this array you have, let's suppose, 5 elements, and in random order, or let me put a different question, okay? So let's suppose you have this array, and in this array you have 0, uh, 1, 3, 2, and 4, okay? So now what I'm saying, that I want to find, let's suppose you are starting your indexes from 1 and 1, okay? So let's suppose this is also 1 and this is also 1. So I want to find the missing number that is there. Obviously this is an index, and 0, 1, 2, 3, 4, this is the size of the array, okay? So now can you please tell me how you can find the missing number in this array? So you have elements that are 1, 1, 3, 2, 4, and now you want to find the missing number that is present in this array. Now there's one more constraint, that the size of the array. Let's suppose in this case the size of the array is 5, and that means you can only store elements 1, 2, 3, 4, and 5 in this array, okay? That is one constraint that I'm putting, okay? So the range that you can only store the elements that are present here, and you can store the elements that are within this range. And one more constraint is there, that only one number is repeated, okay? You cannot repeat all of them saying 111 and then I'm saying find the missing number. No, there is only one number that is repeated, and now you need to find the missing number quickly. Any guesses or anything that is there you are thinking of? Okay, learning, please arrange a series of sessions using C++. Sure, sure, Shit. Sure, Pragyan. The next pointer of last statement should be made 5. Yes, yes, at index 0 this is 1, okay? Let me just clear this. This is 1. Okay. So first reverse according to null. Okay. Sort an array and then use hash map. Okay. Try to not use any extra space. Abhishek says array index out of bound. I am saying that you have the size as 5, and you want to find that repeated number that is there. Obviously, the answer in this case will be 1, that is repeated. No, no, you're getting this question wrong. There is one number that is missing because I told you that in this array the size is 5, and you can only store. I want this array to be in such a way that I'm storing elements from 1 to 5. Okay, so the size of the array is 5, and I can store 0, 1, 2, 3, 4. Obviously, now this is an array, right? And the elements that are there are 5, 0, 1, 2, 3, 4. Okay, now the size according to the size. Okay, now I want to know what is that number that is missing. Obviously, the repeated is 4, and now I want to find out the missing number that is there without using any extra memory. That means you should not use any of the extra memories like array and you're sorting them. You can sort them, obviously, you can do anything, but you don't. I don't want you guys to use any extra space like hash map, hash set. Some of you said, okay. Try to think of things that you have already learned. Okay, so think about it. We will come find the total sum. Okay, okay, Aman, you are somewhere. Okay, good. So let's try to find out the total sum. So 1 plus 1 plus 3 plus 2 plus 4. Okay, now this is the total sum, and the total sum will be 2, 5, and 6, that is 11. Okay, cool. And Sunil says n into n plus 1 divided by 2. Okay, so Sunil is saying n into n plus 1 divided by 2. That is, what is that thing? What is this thing? This n into n plus 1. What are you trying to do? N plus 1. What else? Into n minus 2 divided by 2. Okay, this is what Sunil is saying. Abhishek, can you think of anything? Okay, for loop from 1 to length plus 1. Okay, compare the values. Okay, so these are not sorted. You can compare the values. I try to think of no, something that is much more efficient. Obviously, I can go ahead and see now. Okay, I will pick this element and I will start comparing. Okay, is this element? Yes, so I will be able to find the repeated. So how can you find the missing? I'm talking about the missing. They doing okay. Linear search the num to check. Have you heard about a term that is the sum of the n natural numbers? What is that? GP series. Okay, Prashant Soni says GP series. So can anyone tell me what is the that series, that sum of n natural numbers wherein you have something 1 plus 2 plus 3 plus 4 and so on to, what is that sum? Prashant Soni says GP series. Okay, that is not the case. First do sum, then compare it with the additional first 5 numbers. Okay, so if I'm doing this thing right, let's suppose n into n plus n into n minus 2 or n into n minus 2. Okay, n into n minus 2 divided by 2. Okay, that is what he is saying, Abhishek is saying. So here, what is n? N is 5, that is the size, right? So 5 into 4 divided by 2, that is nothing but 2 2s are, that is 10. Sum of first 5 natural numbers, 5, 4. Is this correct? Is this formula correct, Abhishek? And into n plus 1 by 2, right? So it will be 5 into 6 divided by 2, that is 15. So this is something this. Okay, so now try to find out. Okay, now this is something that you find out. Okay, the sum is what? Let's suppose the sum is 15. Okay, and now the other sum that you find out, the sum of the array is 11. Now try to think of something that is no, square of these things, right? Let me just clear out everything. So now we know, if we do a normal sum, right, sum of n natural numbers, it is n into n plus 1 divided by 2, and the sum of the array elements, that is sum of array elements, it is what, 11 it was, and in this case it was 50. Now if you do the square of these things, okay, try to think of this way. Now let's try to do a square of these things. Like let's suppose 1 was there, 3 was there, 2 was there, this was there. Now think of it like this. Try to square these numbers. Okay, try to square these numbers. So 1 square plus 1 square plus 3 square plus 2 square plus 4 square. Okay, so now try to sum this, compare each element quickly, guys. Try to think of, we are already exceeding the time, so I want to give you a solution. Or you are trying to, will you be able to do this on your own? Do you want me to go to the next thing and try it yourself? Maybe in the next session we will try to see what is the solution. So now obviously the straightforward solution is that you go ahead and find the missing number, that, or find the repeated number. Now you have that repeated number, right, 1 there, right, and now try to find the let's suppose then try to find 1 in the entire array. Then next time try to find 2 in the entire array. Then next time try to find 3 in the entire array, 4, like that. Okay, you can say that, yeah, Pragyan, sort and then compare. Okay, so you have 1 1 2 3 4, and now you start comparing. Okay, you have 1, you are able to find it. Okay, so this is your repeated number, and then you compare it with 2, then you compare it with 3, then you compare it with 4. Okay, done. So now once you have this thing, then you compare it with 2, 3 and 4. So how that thing will help you sorting and then comparing it. Okay, so I will give you this as your homework. Try to find it out. Okay, this is very important and this has been asked multiple times. Okay, try to think of it. Maybe in the next session, any session that I take on this, if it is a continuation, I will talk about that. Okay, so for now let's keep it, just try to think of it. Okay, don't worry. Okay, this is a very important question, by the way. This is asked in multiple companies, Amazon, Facebook, Google. Everyone keeps on asking it, and the companies, they other companies that are apart from these companies that I just spoke about. Those companies directly copy paste these questions. Okay, they will not exactly create their own questions. They will just copy paste it. So now let's talk about this linked list. Okay, so it is also a linear data structure. Elements are stored as per availability. Let's suppose this is the chunk and this is one more chunk, and you want to store the elements. Okay, so you want to store the elements. Let's suppose you have 8 bytes here, 8 bytes here. Okay, so now in array we were not able to store the 16 bytes even if they were available in chunks. Now what linked list said, okay, even if memory is available in chunks, I can store these elements. I just need that 16 bytes, no matter how they are. Okay, I will store them. Okay, so that is one thing, the drawback that was there in arrays, that was removed. Okay, if the number is repeated in the entire array, then swap it with n. You can say that. You have to try it, Durgesh. Okay, you need to try it, you need to implement it, and then you try to debug your program. That is how you learn. Okay, can access elements on linear fashion, then try to optimize it as well, Durgesh. Okay, first try to find the solution. Okay, no matter whatever you are using, then try to optimize it. That is how you learn. Okay, can access elements in a linear fashion. Obviously you can access elements. Now obviously, like arrays, it is also storing homogeneous elements. That means similar type of elements. It is dynamic in size. That means the size constraint that was there in arrays, that is gone. Okay, you need to specify the size. You can only store 5 elements. That thing is gone in linked list. You can store as many elements as you want. Now one more thing is that associated with this arrays is that you cannot directly or randomly access elements. You need to traverse. By traverse means, I mean the one by one. Okay, go here, then go here, then go here, and then finally go to the index that you're looking for. Okay, it is easy to insert and delete, but how you are able to insert and delete, let me give you an example. Okay, so let's suppose you have this array and then you want to insert an element, or not the array, list. Okay, and you want to insert this node, so you want to insert it over here. Now what you will do, you will just cancel this link, put it here, and add this link to here. So only one manipulation was done in order to insert. No swapping, nothing. If you want to delete, let's suppose you're trying to delete something. This is your node, these are your nodes in the linked list, and you want to delete this. Just cancel this link and put this link to this. Only, again, single manipulation was done. That means insertion and deletion is much more easier in linked list. Now if you talk about this particular node, now this node, that the starting node, it's very important, and you have to keep this thing in mind, that you, whatever you do in linked list, never ever change your first node. That is the node that will help you to traverse the entire list. So whenever you're dealing with linked list, whenever you are dealing with linked list, you always store this head node inside another, some temporary node, and call it temp, then manipulate that temp. You never change or do anything that is associated with the head node, because that thing is always that is the node which is responsible for everything. If that thing is changed, your entire list can change. Okay, you are manipulating your entire list. Okay, now if you talk about dynamic size, that is one of the advantages, right? No wastage of memory, because you are not trying to do anything with the size. You need 5 elements, you will use 5 elements to store you will use 5 nodes. Okay, so nothing is wasted. Easy insertion and deletion just by manipulating one link. Okay, so find the total sum using a formula, then finding a sum of array using a for loop, skipping the repeated number. Okay, great. Yes. So once you will now how will you do that? Okay, so you need to first keep the track. You need one more loop to find that repeated number, right? So first try to find that number and then skip it. Nice. Okay, that thing is missing here. Okay, so obviously you have now calculated all the numbers, that is 10 without the repeated one, and you have the sum in place, and then this is your 5 is your missing number. Yes, Aman, absolutely. But now you need to keep this thing in mind. This is the solution, this is absolutely correct, but how many passes are you doing, Aman? That is the thing. You're first using the formula, that is constant time operation. Okay, because you know n. But then sir, what is deep dynamic memory allocation? That means you're trying to store your memory, that is this dynamic size, that you're dynamically allocating memory. That means at runtime, when whatever you're doing at runtime, you are allocating memory. So that is what you mean by dynamic memory allocation. You're not exactly like arrays. In arrays you are specifying, okay, this is the size and I'm going to store these many elements, but in dynamic you're doing that thing in runtime. At runtime, you're not directly allocating this at the start or while compiling your program, you're allocating it at runtime. Okay, that is what you mean by dynamic memory allocation. Okay, so now these are advantages, and you can use your memory very efficiently. Why? What is the storage? Because it contains pointer. Sir, what about storage? Because it contains pointer. Rahul, Rajul, can you rephrase this? What are you trying to say? What about storage? Because it contains pointer. There is no such thing and as pointers in Java. If you're talking about explicitly about Java, then it's not there. Okay, so memory is efficiently utilized, because if you have chunks of memory available here and there, you can still use those chunks. Okay, done. Now what about the disadvantages? Okay, so if head node is lost, entire DSA is lost. Entire you can say your entire linked list is lost if head node is lost, or if you are somehow manipulating it, still you will be losing some information. No random access is possible, because you only have head node present here, and with the help of this head node you will be traversing to the rest of the nodes. So randomly you cannot go to hit this node. Okay, that is not possible. Okay, cool. What about the applications? If you talk about applications, it is used where your memory is limited, because you are efficiently utilizing your memory. So wherever you have that scenario wherein you want to use your memory efficiently, linked list is the thing that you should use. And if you're using an application where you have frequent number of insertions, that means you keep on inserting and you keep on deleting, at that time you will be going for linked list. Okay, because only single link is manipulated. You have seen, right, when you're manipulating this, only single list or single link is manipulated. Okay, so you guys understood what Aman's solution was, right? So what Aman said in that question, 1 1 2, then 3 was here, then we had 2, we had 4. Okay, what Aman said, for the rest of you guys, so that we all are on the same page, what he said: first we are going to calculate the sum with the help of that formula, that is sum of n natural numbers, which is nothing but n plus 1 divided by 2, n into n plus 1 divided by 2, which is n represents the number of elements that are present in this array, which is 5 into 6 divided by 2, that is 2 and 3, that means 15. Okay, this is the size, this is the sum of n natural numbers. And he said, I'm going to first find out what is repeated. Obviously when you loop around it, you will find out, okay, 1 is repeated, because that is the only element that is repeated in this entire array. You will just loop around, find the elements, and you will see 1 is repeated. Okay, so you calculated 1 is repeated. Then what he did, he just said that, and then I will loop around these elements and sum them. So you will do 1 plus 1 plus 3 plus 2 plus 4. He summed them and it came out to be 11, right? 3 plus 5 plus 6 is 11. Okay, then what he did, he just said, okay, now I'm going to remove this or subtract this repeated number from this array. That means now you have 10 and now you have 15. Okay, so now what he did, he subtracted 10 from 15 and he got 5. So that is the number that is missing. Okay, but now I told him, okay, great, you're doing this thing. Now how many passes are you using? 6. What, 6 plus equal to 10? No, Kashyap, I meant 1 plus 1 plus 3, that is 5. So that is what I meant by 5 plus 3, that is 6. Okay, so 1 plus 1, it is 2, 2 plus 3 is 5, 5 plus 2 is 7, 7 plus 4 is 11. So Kashyap, why you are saying 10? Because we are subtracting, then it is 10. Okay, yeah. Okay, cool. So now try to think of how many passes you guys are using. Okay, so now let's see the list. Okay, so what is the structure of this list? So you're going to use a class, okay, and that is linked list node. And then what we are doing, we are going to declare two data members in that class. That is, one is data and the other is a, we can say, the reference to the same node. Okay, so obviously this part will contain the reference of the next node that is there. So that is why it is of type linked list. Okay, the type of this next part is the linked list. So you have these data members available. Let me just clear out screen. You have these data members and your node will look like this. This will be your data part and this will be your next part. Now next part will contain the reference of the next node, data will contain your value. Okay, now you also have a constructor over here which is just used to initialize this node whenever you're trying to create. Priya says okay, she doesn't understand. So you understand this, right? That what we did, we just traverse and then found out these things. Okay, don't go into the other scenarios, what I said in terms of phases. You understood this. That is for the guys who are trying to optimize it. For you, you can just think of this as a simple solution. Okay, just to keep it as simple as for now. Okay, so that you are not confused anywhere. Okay, so now this is the linked list and then it is used, this constructor is used to initialize this. So this dot data, you can initialize this, and this pointer si, where is it, this pointer si. Okay, so now what we are doing, we have this data part and we have this next part. So this is the linked list constructor that we are going to use to initialize these things. Let's suppose we are creating, or we are creating an object, and then this constructor gets called, and then you're passing some argument, let's suppose 5. At that time this data part will contain 5 and this will contain null. Okay, this is a keyword. Yes, Abhishek, this, okay, he's saying this point is pointer. No, this is a keyword. Okay, this is a keyword and it is used. Now there are two things. So this refers to the current object. So whatever the object it is calling, it refers to that same object. Okay, cool. So now let's try to insert an element at the beginning of the linked list. Okay, so if you have this linked list, right, You have this linked list, right? And now you're trying to insert, and you're trying to insert always at the beginning of the linked list. Now what is the thing, how can you do it? Now you might be thinking, okay, we are trying to insert, but can there be two scenarios wherein you're trying to insert this thing? Yes. So the first scenario is that your entire list is empty and you have no element, that is you have your head node is at null. So remember this head node, okay? You can say that this is a pointer. Basically this is the this refers to the current object. You can say this is a reference. There is no such term as pointer in what Java. This is a reference, okay? Yes, Kashyap, yes, you can say that. Okay, so then you have a situation wherein you have multiple number of nodes. Okay, done. So now what is happening? So we will consider both of these cases. Okay, let me just erase everything else. Now obviously when you talk about this head node, this will contain some reference. It can be either null or it will have the reference. Let's suppose at this time, for simplicity, it is what? This will help to identify the new instance of a class. Yes, Aman, you can say that. Okay, so this refers to the current object. Okay, so now this head is the reference of this node, that is 1000, let's suppose. Okay, so now obviously you will be having some key because you are trying to insert, this is the item that you're trying to insert. Let's suppose you're trying to insert 10 in your linked list. Now you are creating a node here with the help of new keyword. You are allocating memory and you are passing this key, that is 10. Now remember, whenever you are creating an object at that time, whenever you have this encountered, this new is encountered, that means you are allocating memory. And whenever you are creating an object, a constructor gets called and you're passing in 10 to that. So this constructor gets called and in this data you have 10. Now when you have this 10, you're creating a new node and you have this as 10 and you have this as null. Obviously this will be having some reference, let's suppose 10,000 for simplicity. Okay, and now once this is done, and then what you are doing, you have this temp pointing to that new node. So you have this new node and it contains 10. This is null, this is having some reference, and this is temp that is pointing to this node. Done. This is what happened in this single step, that is this. Okay, in this step these things happened. Okay, done. Now can you help me? I don't understand, can you help me? What is the thing that you are not able to understand? Okay, so now what is happening? Now you will check, okay, if head is null, let's consider the case where head is null. Yes, it is. Then head will be pointing to this temp. So you have this head that is pointing to this temp. You will not go into the else part and you will return this head. That means the reference of this head, that is 1000. Okay, done. So you have your insertion at beginning done. But now let's suppose you are having one node. Let's consider the case wherein we just created a node. So now let's suppose you have this node wherein you just created a new node, and now you have this as head and this is having a reference of 10,000 or 1000. So we have this 10,000 in this head node and you have this key. Now this time around you are trying to store 20. So what will happen when you're having this function or when this statement is executed? Again a constructor will be called, again a key will be passed, that is this 20. You will have this 20, you have this null because of the constructor. Okay, there is single L. Yeah, you have this null. Okay, done. Yeah, so you have this null and you will have some reference. Let's suppose this is 20,000 and then this temp is pointing to this. Okay, done. Now what is happening? Is our head null? No, head is not null. Now we will go into the else part. Now what is saying? He's saying that in this what you will do temps next. Whatever is in the temps next. What is in the temps next? It is null. Please go ahead and store head in it. What is head? 10,000. So we store 10,000 in it. And then point this head to this temp. Now head is pointing to this temp. This is done. This is gone. Now can you see that this element is lost or this node is lost? No, the link is already created. We replaced this null by 10,000. So you have this link like this. So in a nutshell, if I put it in a much more elegant way. You have this 20, and then you have 10,000, the reference pointing to this node. You have this 10, and this is pointing to null. This is 10,000, this is 20,000, this is your head, and then at the end you are returning this head. So what did you do? You did nothing but inserted an element at the beginning of the linked list. Okay, that's it. Is everything clear? Is this thing clear to you guys? Is this insertion at beginning clear? If yes, then it's great. If not, I'm going to repeat it. So anyways, we are just about to conclude this session as we are running out of time. So don't worry. Okay, so don't worry. Today we are going to release a video on entire data structures and algorithms, and we will be implementing everything, right? The data structures and the algorithms using C. Okay. So what is this JK? Okay. Okay. Cool. So if everything is clear, I think you're not saying your doubt, whatever you are trying to say. Flotra. Okay, Durgesh says please repeat. So basically what I'm trying to do, I'm trying to insert an element at the beginning. So with this statement, we are trying to create a new node. We have created a new node, right? This 10 and this is null. And then what we are doing, we are just allocating memory, right? This is our head node now, okay? Then if this is the first node. Now next time around what we are doing, we are checking if this head node is here. This time around this head node is present because this head node is not null. Then we created a new node that is 20, and this is also null. Okay, this is a reference of 2000. This is a new node that is TMP. Okay, this temporary node. Done. Now this time around we are checking, is this null? No, it is not. We are not executing this block. Now we go into the else part. Then what are we doing? We are just checking, okay, whatever was in the temps next, that is null, put head in it. What is head? Head is 10,000. So we put head in it, and then we are pointing this head to this new node that we created. So this is gone, and this has been linked with this node. Okay. So guys, what we are doing now, we are going to today we are going to release a video that is a 10-hour course on data structures and algorithms. Everything will be explained: arrays, linked lists, stacks, queues, trees. Okay, then some algorithms there. So everything will be explained, and we will be implementing those algorithms and data structures using C. Okay. What about insertion at the end? So that thing is also present in that video. Okay, this is just a prerequisite, guys. So I was planning to explain you guys at the end as well. So Kashyap, what you are going to do when you're trying to insert an element at the end, you will traverse at the end and then insert. So you will use a while loop. You can see the else part here. I'm using a while loop to traverse. Okay, to traverse I'm using a while loop, and once I will be at the end, and then I will be inserting it. Okay. So dynamic arrays like array lists and linked lists are same or different. So Aman, these are different. Even if linked list, even if you are thinking it as a size in terms of size only, right? So because if you talk about linked list is stored in such a way that even if you have your memory chunks available here and there, you can still store. But dynamic size array is just the same as array. You need a contiguous memory allocation. But the thing is that the size is dynamic right now. You can just allocate dynamically your size. That's it. But these are two entirely different things. Okay, though that thing is still the array. Okay. Cool, guys. So today at 5:30 we are going to release that video. Make sure you check that out, and if you haven't subscribed to our channel, make sure to subscribe to our channel, and also share and like this video, and plus go and watch that video which we are going to release at 5:30, and in that video everything is explained. Okay, cool, guys. So thank you so much. I hope you enjoyed this session, and now we'll be concluding this session. Okay, thank you so much, guys. Thanks a lot.